live from the Orion Cygnus arm of the Milky Way galaxy. This is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, pretty good.
And our special guest for today, returning from the depths of the universe, is Seth Lockman. I forgot your DJ name. You had one.
Oh,
Marvel Man.
I thought it was Star Watcher, like the
That was
chimp
Bernie.
from 2001. No, was that Bernie?
Yeah, that was me. Yes, Sean.
Oh yeah, it even says in the notes you're Star Watcher. Man,
we can't have the
look
same
at me
name,
trying to
Seth.
steal your handle. I'm sorry.
Yeah, right.
So
I don't know. I could pull
don't
it up in the old
remember your-
notes.
Yeah.
Sorry
Falls
about
to
that,
Google.
Seth. I forgot to do that historical research. But you are the one, the only man on the Lego moon, purveyor of the legendary sextants of appreciation, and entertainer of astronomy audiophiles. Welcome to the show.
Thank you, Sarah. It is good to be back.
Reach out to us at WMPG Scientifically Speaking at gmail.com if you've got anything to say, or Twitter at WMPG SciSpeak. You can DM me. Bernie,
Yes.
what's up in the night sky for this coming week?
Okay, we have a much better than usual week coming up. So it'll be almost new moon. It'll be waning crescent moon on Friday. And the main highlight, of course, will be the comet NEOWISE. A lot of people have been asking me about it. I haven't seen it yet myself, but it's very easy to see, and I looked up a bunch of excellent photographs. This will be the best comet since Hale-Bopp way back in 1997, 23 years ago. So it is naked eye visible. For a while it was morning, but now it has become an evening comet, and you should try to catch it while the moon is not in the way. You can see it just below the Big Dipper, and then it's going to head over to Coma Berenices and down into Virgo eventually in August. So try to catch it while the moon isn't that full. So it's a really neat comet. We'll talk later about how it was discovered, but NEOWISE is an acronym. It's not a person's name. So it's Near Earth Object Wide Field Infrared Survey Explorer. So it's a nice little satellite we have up there, about 330 miles up, and it's already found hundreds of comets and all kinds of neat things. So it's important that it's up there looking for this. So we can look for that. And then Jupiter has just reached opposition. I saw it last night right after sunset. It means it comes up in the east right when the sun sets in the west. And then Saturn's going to be opposition next week. So it's coming up right after sunset. Venus is a morning planet, and Mars comes up around midnight. But the highlight definitely will be NEOWISE. Look up some photographs, try to get some of your own pictures, be aware of what this comet is and how it was discovered and why it's important. It's not coming back for 6,800 more years. So definitely try to catch it this time around.
Thank you so much for that, Bernie.
Yeah, you're welcome.
So if Bernie talked way too fast for you, you can also check out the monthly What's Up column in the Portland Press-Herald, where you can read some of this information instead. So for today's show, and the whole reason why Seth is with us, is because he is an expert on robots and their observational skills.
I am.
Yes, you are now. So say yes. You are.
I feel like Captain Kirk's dad in the reboot. Okay, I got this.
All jokes aside, the inspiration for this show is actually Bernie, you had talked about NEOWISE, and you had mentioned another comet last week. I couldn't remember the name. Yes.
Pan-STARRS, yeah.
Yeah, and that was the first time. I'm not a astronomy, crazy loco lover like you two are. I mean, I love astronomy, but nowhere near the same degree. And so I had no idea that there were comets that were named after telescopes. And so I thought that was really fascinating, and how, you had mentioned, they're named after telescopes who discovered them, and then people who, I guess, learned about it after it discovered it, something like that. I don't know. And so we thought it'd be a great idea to do a show on automated astronomy and have Seth join us in the conversation. So we have a lot of juicy stuff on automation and robots and technology for you for this show.
Yeah.
So thank you, Bernie, for talking a little bit about NEOWISE. But one of the things that you had mentioned was, well, first you told our listeners to go to read more about it and learn how it was discovered. But can we actually tell them right now how it was discovered?
Yeah, okay. Well, it was discovered fairly recently. It was March 27th of this year. And when that satellite, which is a little satellite that's up there, as I said, like 330 miles up, it is basically doing a sky survey. So it has discovered over, let me see, 158,000 asteroids. A few of those, the ones we're interested in, are the potentially hazardous asteroids, or PHA. So that's, you know, it's a good purpose. But even beyond that, we're just trying to learn more about the science and see what these objects look like in infrared. So it was 17th magnitude when they found it. Of course, they were analyzing the data, this being not a person or looking through the telescope. So now it is actually 1,000,000 times brighter. It's 15 magnitudes brighter when they first found it. And that's a pretty quick brightening. And that often happens when it's not a regular periodic comet that comes back all the time. Now, a lot of the other ones we'll probably be talking about, they're on the ground base. So this is different. NEOWISE is an orbiting satellite in low Earth orbit at 330 miles up, looking for a lot of other things than just comets and asteroids. Yeah.
How many, let's just talk about comets specifically. Do we know how many comets have been, quote unquote, discovered by telescopes?
Probably a lot more than you would think, because a lot of comets also hit the sun. So three other telescopes, which each have discovered like 20 plus comets, NEOWISE discovered 21. It actually found 155, but most of those we knew about. It discovered 21 new ones. So Pan-STARRS, Linear, and NEAT, again, all acronyms, they each found 20 to 50 comets. So I'd say hundreds and hundreds of comets have been found this way.
So then how do they, if NEOWISE has discovered 21 different comets, why is only one of them named Comet NEOWISE?
Because they're probably not bright enough to even be able to see with normal, it gets a big thing if even binocular visible. A lot of these might be 10th magnitude or fainter.
Yeah, that is a good point, though, because it's a tradition. If a single person discovers multiple comets, they'll kind of add a number on the end of it, which is how you get something like Shoemaker-Levy 9. Yeah.
Yeah, exactly. Yeah.
So this should be NEOWISE 21, huh?
Yeah, well, theoretically, but it's the only one that really anyone would be interested or could even find without a monster $1 million telescope.
Yeah, I guess.
Yeah, like Pan-STARRS had 3 or 4 or 5 or 6 that became really bright. Linear, I know Linear had at least that many. I mean, it had dozens and dozens, but that became bright enough to attempt for normal people to find. Comet NEAT, I think it had 2 or 3. Linear had 10, and Pan-STARRS had 20 or whatever that we could actually look for. Yeah.
So I wonder if, do you think that having the comet be named after, well, so there is probably somebody who realized that NEOWISE found this comet, right?
Mm-hmm. Yeah,
Yes.
The data had to be analyzed by humans.
So why would they not name the comet after the person who did all the analysis?
Oh, yeah. Well, that would make sense, I suppose.
I have a theory.
Yeah,
What's
go ahead.
that theory?
I think it's because they're amateurs.
Oh.
Yes. Comet NEOWISE, the principal investigator was Amy Mainzer, who is employed by the University of Arizona. So she's an actual astronomer. I think that the night sky could have more comets that were named after women. That would probably be a good thing, but okay. But I looked at some other ones. The comet Pan-STARRS, well, one of them at least. This is comet 2011 L4. That one was discovered by Richard Wainscoat, although arguably it was a Russian amateur astronomer, Denis Denisenko, who noticed that the orbit was remarkably comet-like and that it might be a comet. Then we've got Atlas. Comet Atlas was discovered by 2 guys on a messaging board, Sam Dean and Tony Dunn. Comet Swan was discovered by an amateur named Michael Matiazzo, and he's like discovered 8 comets just going through the data of this one instrument on SOHO, the Solar and Heliospheric Observatory. So I don't know if any of them actually got named after him, but I did notice this pattern that if an amateur detects the comet, then it gets named after the telescope. Now, the exception to this is Comet Borisov, the second interstellar object ever detected, and I think the most recent, because he personally owned the observatory. So they, calling it Comet Margot would have just been kind of shooting themselves in the foot because it's his observatory. So they're like, you win this one, Borisov. But I think that they're just trying to push amateurs out of the limelight for the most part by adopting this naming scheme. That is just my personal opinion, but I do call upon the International Astronomical Union, my old and kind of favorite nemesis. Just give credit to the people who discovered the comets. It's been going on for hundreds of years. It's fine. It's one of the few naming conventions from astronomy that I actually like, and it won't kill you to give to people who deserve the credit.
Mm-hmm. Yeah.
Right, because I mean, what's interesting is, I guess, Seth, you could have looked through your telescope and observed a comet, and then what if I pushed you out of the way, beat you up, and then said, looked at it, and then said, I was the one who observed it.
Yep.
I mean, like that person would get credit, but
Right.
in this case, these amateurs are doing all this. It's a lot of work. I mean,
Right.
I'm assuming they're processing all the raw data and they're, doing some, whatever to figure out this, whether or not it's a comet or some other object of interest.
Right.
And I feel like that's a lot more work than just seeing it.
Yeah, and also it's not like the telescope that made the detection is going to be kept out of the press releases or anything. They're going to get the limelight. The multi-billion, well, probably not billion, but hundreds of millions of dollars project. I mean, they'll get their due. They'll get the recognition. It just, if someone discovers a comet, you name the comet after them. That's the tradition.
Yeah.
Or I mean,
Whoops.
I almost wonder if, what if you were the one who wrote the code to do the autonomous, observation? Why don't you get the credit?
Well, that is a really good question. I mean, eventually we'll have to get into kind of cosmological copyrights. That'll have to become a thing.
Yeah, we're going off.
There's an exciting futurism concept that you don't get to hear much about. Yeah.
Well, okay.
Oh yeah, just speaking of things which may only be interesting to a few people, I did dig up our old DJ names. Sarah, you are DJ Galaxy.
You did this while we were talking about all
whilst ranting. I am that good.
I do remember I was Galaxy Girl.
Yeah, and I was DJ Marvel Man.
See, I said that.
Oh, so she was right.
You nailed it.
I wasn't sure because I thought Marvel Man was like a superhero from.
Oh, that's Captain Marvel, I think.
Oh, okay.
Yeah.
All right. So I didn't want to give you the credit for something that maybe that you didn't even dress up for Halloween for, or All right. So that was a little bit on comets and how some of them are discovered by telescopes and their great automated observation skills. But I'm also curious about kind of the history of automated telescopes, because there's all different types of, or rather levels of automation. There's, you can write a code and have something kind of express that code in a step-by-step fashion. You can say, okay, if you see this, tell me, and I'll do something about it. Or it can be fully automated and have, some semblance of intelligence with machine learning or, whatever. But I feel like somebody who kind of, I guess, I don't know what you call it, was the inspiration or kind of thought of a lot of the ideas that make some of the stuff that we have now possible.
Wait, who, Jeff?
I don't know who Jeff. Who's Jeff?
Yeah. No, so automated astronomy was popularized by Arthur C. Clarke, and it appeared in some form even as far back as 2001, when we know that the computer HAL has cameras all over the ship, including the exterior, and so he's able to complete some kind of deep sky surveys when he's so far out from the radio noise of Earth. But the first time that we really see like a concerted human effort at automated astronomy in the zeitgeist is his 1972 book Rendezvous with Rama. And in this book, this is like the first chapter and a half. This is just the setup for an even more important, like this could be a novel, to me at least. But so in September of 2077, an asteroid impacts northern Italy. 600,000 killed, another million suffer permanent hearing damage, other injuries just all around. There's catastrophic trillions of dollars of damage. And so as a result of this catastrophe, the spaceguard is created almost immediately, which is this kind of, it's implied that it's kind of this world level organization, and their goal is to detect asteroids that might potentially hit Earth and then redirect them if necessary. And so a couple of decades later, by 2130, they've got all these different listening posts. It seems like most of their operations are based out of Mars, which kind of gives you a leg up on the sun's gravity well. And it's entirely automated. Supercomputers are detecting these asteroids, calculating their orbits, and storing their information in some sort of an academic database. The focus is on identifying near-Earth objects and Earth-crossing asteroids, and the database is accessed, every few months, kind of by curious scientists. And then there is some automated system that alerts SpaceGuard headquarters if ever an interstellar object is detected, and presumably there are other kind of parameters as well. And so then it's
oddly familiar to
right.
what we were just talking about,
doesn't it?
Yes.
Now, Clarke was wrong about two things in this uncannily, prescient little bit of writing. The first is that asteroids which impact the ground are typically kind of metallic, and all things being equal, actually less damaging than icy asteroids, which are more prone to exploding in the air. An asteroid which impacted the ground and caused the kind of damage that Clarke mentioned in the book would also create so much more damage that it just wouldn't, it would just be much worse. But what he was describing is damage that was kind of more consistent with an air exploding icy asteroid. But okay, the other thing is that now we know that if over 500,000 people died and roughly another million were permanently injured in an international crisis, some countries might do something, but the human race as a whole, or let alone the entirety of the industrialized world, would not necessarily immediately pitch in to preserve life, which I just thought was kind of a sad thing to reflect on. But anyway, this book really laid the groundwork, and in 1992. The SpaceGuard survey proposal was published. It was this ambitious international network of ground-based telescopes. The goal is to decrease the monthly discovery of near-Earth objects by up to like 3 orders of magnitude. And they cited Rendezvous with Rama as kind of the inspiration for the name. And since that time, SpaceGuard has kind of become more of a collective noun, kind of verb, adjective thing. It's kind of like SETI, although SETI also has there's an organization called SETI. But then you would also say, oh yeah, I think SETI is cool, like just the act of searching for extraterrestrial intelligence, right? And so SpaceGuard is just kind of the act of trying to detect these asteroids. And I'll just kind of, there's a whole bunch of more stuff here, but
I'm curious, what is who or what is Rama?
Yeah, so without saying too much,
is this a spoilers alert?
Yeah, sure. Spoiler
alert. A long time ago.
Yeah. So yeah, they detect this asteroid, which is either not tumbling at all, which is kind of weird for an asteroid, or it's just perfectly uniform in its surface composition, which would also be weird for an asteroid. And it's coming in really fast. It looks like it's an interstellar object, and it's really, really big. And so eventually they ping spaceguard, the headquarters there, and they decide to name it. They call it Rama because they've kind of run out of Roman and Greek names at that point, so they're on to the Hindu pantheon. And then eventually they discover that, you know, whatever it is, it's definitely not an asteroid. And I'll just leave it at that.
Wow.
Ah,
The
could be something
suspense.
alien cultures. That's good.
Yeah,
You thought by listening to this show you would have all of your your questions answered.
Yeah.
But instead, you just have more questions.
Yes, that's right.
Yes.
We can't answer everything here.
No.
No, no good.
Said directly from the one and only Bernie.
Yeah.
No, that's incredible, actually. I wonder if, I mean, you know, I guess post World War, II, the idea of kind of international organizations is really not that new, right? We have the UN, we have the WHO, we have, I don't know, other like IMF, whatever. And so the idea of a space guard doesn't really seem that far off, with considering those types of organizations that existed at the time, or existed by then, because this was in 1970s, right?
Yeah, it was 72.
Okay.
And
So I'm curious, what was his inspiration? Do you know?
I don't. Arthur C. Clarke invented a lot of things. He literally patented the radio satellite. And a lot of the things that he came across, he just thought were interesting or plausible. And a lot of his stories are about some technology and how it's made to work. So no, I don't know exactly how he came across it. I do know he basically popularized it. He did write about it again in 1993 in his book, The Hammer of God. And so this is kind of hyper real, right? Because 92, you have the Space Guard survey. And then in 93, he writes a book where NASA in the 1990s creates a Space Guard survey. Although this version of the story is a little bit less optimistic. So in this one, Space Guard is still a distinct organization. It's not like a general term for effort. And again, they're mostly Mars based, and they have all these intervention strategies, a couple of ships standing by to go and intercept an asteroid that might impact the Earth if they need. And then ultimately, the Kali, the asteroid in this book, which does turn out to be an asteroid, spoilers, is detected by an amateur astronomer who is using automation. He's using the auto search hardware is the term used in the book, and he detects the asteroid Kali. And then it turns out that once everybody starts checking their data, that SpaceGuard detected this asteroid 3 times before the amateur, but the signal was below the threshold of noise, and so it didn't trigger any sort of warnings, and so that's how SpaceGuard missed it. And unfortunately, what we got in real life with the UN's International Asteroid Warning Network and NASA's Planetary Defense Coordination Office is kind of more keeping with the Hammer of God version of SpaceGuard. SpaceGuard failed to detect the 2002 Eastern Mediterranean event, the 2002 Vitim event, the Chelyabinsk in 2013. All of those superbolides, no detection at all. But there was one exception. On October 6, 2008, a scientist or a team led by Richard Kowalski, Catalina Sky Survey at Mount Lemmon detected asteroid 2008 TC sub 3 on a collision course with the Earth. 19 hours later, the asteroid exploded over Sudan. So that wasn't really enough of an advance notice, in my opinion. But this is an example of kind of trying to apply the principles of automated astronomy. And clearly there's some progress to be made. But in terms of cataloging near-Earth objects, actually, the Planetary Defense Coordination Office has made a great deal of progress.
Yeah. I mean, that your kind of advance notice kind of reminds me of there's like some technology that can help you identify if you're going to have a stroke, but it usually only gives you about like 5-second notice.
What?
Yeah, like it's a really small time frame, and it's just not enough to really do much with. Um, but that's so fascinating that basically everything that we talked about in the first half, you've just summarized it as like a two-part book.
Yeah. Yeah. That's Clark for you. He's really influential. Yeah, and even Pan-STARRS, correct me if I'm wrong, Bernie, but I think Pan-STARRS is part of the whole general spaceguard effort that they're trying to detect Earth-crossing asteroids.
Oh yeah, that's the main reason for that, linear and neat and probably even Swan. Yeah. Yeah, that's the benefit to us. I mean, it's nice scientifically to know about these things, but if it's dangerous for us, we can. And now we know more about comets and asteroids. We can actually do something about it. It's called a gravity tractor. We don't want to blow it up.
Yes.
You just want to put something near it. Once you can really calculate the orbit very precisely, then you have to move it just a few meters maybe out of the way. Don't move it the wrong way. It'll make it worse. And it'll miss us, or it might even bounce off the atmosphere and not hit us and that type of thing. Just a gravity tractor. So just using the principles of physics and some good knowledge in orbits, we can do that.
Mm-hmm.
Yeah.
Wow.
Yeah.
What if you accidentally moved it out of the way enough that it hit our moon? And then we lost our moon.
Well, you wouldn't lose the moon. The moon gets hit fairly often by things, actually, and it wouldn't be a problem at all. That would be
like a large catastrophic one, though.
To overcome the binding energy of the moon.
Well, that would be really huge. I mean, because, Jupiter, a lot of them hit Jupiter, and that actually helps protect the Earth. So it's really good. Mm-hmm. Jupiter like a giant vacuum cleaner.
Yeah,
exactly. It is. I mean, Shoemaker-Levy 9, exactly 15 years later to the day, another comet hit Jupiter. And it probably has happened millions of times in the past.
Yeah. Shoemaker-Levy 9 is described as being kind of a real kick in the pants for the detection of near-Earth asteroids. That people, the destructive power, the awesome power of those collisions, every one of which was like greater than the entirety of the world's nuclear arsenal. That kind of damage from these fragments that were like no more than half a mile across, that really woke people up to like, okay, we need some sort of space guardy something. Yeah, but it's not just space guard, is it? Right? Because SETI is basically automated, and even telescopes that are basically told where to point by astronomers, they're basically acting by themselves. That like a huge part of modern astronomy is just kind of writing a program, right?
Yeah. But that program is hard to write.
Oh.
I mean, just kind of traditional astronomy has relied on visible light, but 1% of all electromagnetic spectrum is only visible light. Like only 1% of it is, and so there's so much information out there that kind of like you were saying, Seth, a lot of it gets missed because it's below the noise level, or whatever that is that we can right now detect. And then, with more like bigger telescopes, more sensitive telescopes, higher resolution, I almost wonder what if it is possible that, say, the US's enemy, whoever that might be, or whoever, that all those countries could be, could they be developing telescopes? Is there a race to develop telescopes with higher resolution to identify objects of interest, and unlike using your gravity tractor to move it away, but to try and move it to target? I wonder if that's possible.
Oh,
that's some Starship Troopers right there.
Yeah, they could, but that would be self-defeating. If they don't move it properly, they'll blow themselves up. So
I mean, there's a lot of risk in a lot of those bombs, right?
Yeah. Well, yeah, that's true. No, I never thought of that. I mean, that's bad enough with the nuclear weapons. We don't have to start aiming asteroids at ourselves on purpose.
Oh no. Well, on that happy note, yeah.
Yes. Okay, yeah.
Actually, I can say real quick, exoplanet detection was a case. It wasn't a case of noise threshold. It was a case that nobody thought that their hot Jupiters existed, that a planet more massive than Jupiter could orbit that close to a parent star. So they just the robots. Oh, here's my bird clock. So the robots that they. So the robots or the computer program. They're done. You're done. So the computer programs they wrote to find these stars, or sorry, the computer programs they wrote to find these exoplanets, even though the hot Jupiters were well above the signal to noise ratio, they just weren't looking for it, you know?
Yeah.
And so once they finally found one in 92, going back, they immediately found like 2 more in the data that they had already collected.
Yeah. We have come to another end of a fantastic show of Scientifically Speaking. At least we think so. Hopefully you think so as well. You have been listening to Scientifically Speaking here on WMPG with me and my 2 favorite astrophiles, Seth and Bernie. Stay tuned for songs from Mother Russia and her neighboring countries with our tour on Zuki to Sea. And from your favorite nerds, we wish you safe viewing and clear skies.